Are we filming?
Yes.
I heard something else. I don't know what I heard.
What thing?
Saturn.
Let's talk about Saturn, chapter 27. That's what you got to read tonight. Now, Saturn is the second biggest planet in the solar system. Its volume is 755 times Earth's volume. Do you remember what Jupiter's was? Did it say?
Yeah, 318 times.
More.
60,000.
1,300.
Yeah, about I was going to say about 1,000. It might be bigger than that.
1,300 times Earth's volume.
Jupiter was 1,300 times as big as Earth. Saturn 755 times as big as Earth as far as volume is concerned. Jupiter's so big it could actually swallow up all the other planets in its volume.
That's cool.
So Jupiter really big, but Saturn is also big. It's over half as big as Jupiter, and Saturn is the only planet that has rings that are visible from Earth. Again, we talked about the rings a little bit already. The rings can form different ways. It's thought that Saturn's ring probably formed from a moon that spiraled in closer and closer over millions of years and eventually got so close that it got broken up. Do you remember the name of the zone? If you get past that zone, the gravity will tear a body apart. If it's any body held by gravity, will be torn apart. 10 points if you can name the limit. It's a something limit where if you get closer to that, you'll be torn up by gravity.
All right, everyone, get thinking.
You're a pro.
Hey.
Aubrey.
Amir, what do you think it is?
Yeah, teacher.
Oh wait. Oh shit. What is it?
White is correct.
I don't know.
Yes. No, it's the roach.
Oh.
I thought it was roach.
Orange is correct.
Oh, sorry.
All right. You want me to bring it
Purple
up?
is correct. Anyone else?
Yes. On film.
Blue is incorrect.
Blue correct.
Oh yeah.
It's the roach limit. The roach limit. So this could have been created by a small moon. They got torn apart. And if that is the case, then it'll probably continue to spiral in, and these rings will disappear over millions of years. So that's how some rings form, but some rings don't form that way. A ring could also be formed by just material that's moving fast enough that is so close to the planet that it can't form a moon. And it could have been there for longer, but they're trying to figure out how that ring formed. A ring can also form by a moon that's going around and spraying off stuff like Io sprays off volcanoes that shoot way high out and will leave the gravity of the moon and can form a ring because it's constantly shooting this material out and it forms a nice ring around the planet. So rings form different ways. The ring is made mostly of gas and dust and especially water, frozen water, so ice. These ice and dust particles will stick together as you're going around the ring. I think I've heard that the average size of a ring particle is about the size of your fist.
Oh.
So most of the stuff that makes up that ring is about the size of your fist. Some can get bigger, some smaller, but pieces when they hit one another sometimes stick together. Yeah.
So why are the rings from Saturn so visible?
So visible?
Yeah.
Because there's so much stuff there. And the sunlight bounces off of it and we can see it. So no other planet really has that much stuff to form rings.
We got this stuff.
Earth actually has a man-made ring. Did you know that? It's a ring of satellites that we've put up there that are orbiting the Earth. And it forms a nice little ring if you can see it, but it's so small you can't see it. But anyway, pretty interesting. Saturn is the least dense planet. It's a gas giant. It's made of gas. Again, hydrogen and helium. But since it's not as heavy as Jupiter, it doesn't have as much gravity, and that keeps the gases kind of spread out more. And so the overall density of the planet is less than the density of water. And what that means is, you'll often hear this, if you had a bathtub big enough and you put Saturn in it, Saturn would float.
Oh my
It's
god.
the only planet with a density, overall density, less than the density of water. Every other planet is more than the density of water, and so it would sink, but Saturn would float. That's kind of a common thing you hear thrown around about Saturn, that it's low density. What planet has the highest density? 10 points if you can guess that. What planet has the highest density? Saturn has the lowest. I won't even count off if you're wrong here. So you can just guess. What planet has the highest density?
It's definitely Pluto.
Definitely, because we talked about it already.
Venus.
Density meaning
How compact it is.
You put Earth?
Oh, man.
Matthew.
Oopsies.
You wanna go for it?
We're still filming.
White is wrong.
Oh.
Blue is wrong.
Oh no, we're wrong.
Here we go.
I'm not counting off if you're wrong. Purple is wrong. That's a good guess.
Except you, we won't get it all.
Anyone else? Orange is wrong.
It's Earth.
Peach is wrong. Nobody got it right. It's Earth.
Yay!
The Earth is the most dense. Venus is close and Mercury's close. The terrestrial planets are going to be more dense than the gas giants, because gas giants are gas mostly.
I
So,
thought Venus would be more dense because of the clouds, like how thick everything is.
well, that's atmosphere. Atmosphere is not very dense compared to rock. Rock.
But I thought it was like 95% of like greater.
Yeah, the atmosphere
Stop,
is thicker,
dude.
but the rock of Venus is not as dense as the rock of Earth. And there's way more rock than there is atmosphere.
I think Mercury
move back.
Yeah, now you're right.
like the scar.
Yeah, it's still not quite as dense. It's close. It doesn't have as much metal in its core. Earth has more metal in its core, so it makes it denser. Saturn orbits the Sun once every 30 years, so I am only 1.5 in Saturn years.
Okay, why is Jupiter, Saturn known as the father of Jupiter?
Well, they discovered
What?
That's all.
that Saturn was further out than Jupiter. Maybe maybe they wanted
Because like
it to be
Jupiter's
the father.
bigger. I mean, it's like.
But see, when they're looking at these stars, they didn't know how big Jupiter was. They didn't even know they were planets. They were looking at dots in the sky when they named these things way long time ago. I don't know why they named it Saturn, but Saturn is the father of Jupiter. So maybe because it moves slower, and so they thought it was an older man. I don't know. I'm just guessing.
Okay.
Saturn's atmosphere, again, is hydrogen and helium. It happens to be 92 and 7. Do you remember what Jupiter was? Hydrogen and helium percentages?
Yes.
90 and 10.
90 and 10. They're all around that. Even the sun is around 90 and 10. I think the sun is like 94 and 6 or something like that. But anyway, most stuff in the universe is hydrogen and helium. The upper atmosphere has clouds that rotate 1,100 miles per hour. Jupiter's winds were only 400 miles per hour. Saturn's winds are 1,100 miles per hour is how fast the atmosphere is moving. It's crazy, yes.
How did the hydrogen and helium get there?
That came from the original universe. So the universe at one time was all energy, no matter. And then some of that energy froze into matter and formed the simplest atoms, which are hydrogen and helium. And from those formed stars, and from those the stars would explode and form supernovas and form all the other elements. We're going to learn about all that later.
Okay.
It's a great story, though. The only thing we don't understand is how the universe got here to begin with.
Crazy.
But we can understand pretty much everything all the way back until what they call the Big Bang. Have you ever heard of that? Which is the origin of the universe. We really don't understand how that happened. I'm working on it right now. Theoreticians are
You like that shit?
coming. Have you ever heard of a thing called quantum physics?
I
Have you
have.
ever heard of a thing called string theory? They're trying to work out how the universe got here. And maybe they'll get that one day, but maybe not. Who knows? Anyway, we learn about that toward the end of the year here.
We should watch Neil deGrasse Tyson's
Yeah.
Netflix show, Cosmos.
He's coming to Jacksonville in November. It's sold out. I'm trying to get tickets.
Wait, who is that?
Neil deGrasse Tyson.
We should take an astronomy
He's so
field
cool.
trip.
That would be great.
That's
Yeah.
my
Oh no, we're gonna try to go to the
He's an astronomer.
the big telescope up in Yolonia. I'm trying to line that up.
Oh, really?
It has to be a clear night though. See, so we gotta.
Oh my gosh.
Like,
It's gonna probably be last
Yolonia,
minute.
like right by Macintosh, Yolonia?
I love
Yeah.
that.
That would be so
There's a
cool.
farmer there with a big telescope.
Oh,
And he's
Mr.
got
Willis, that'd be
it's in a barn. He can open the roof.
Wear a bullet tag.
His name is I'm forgetting.
Like all summer, I just
Forget it.
Is it the Buffalo Farm? Or is it a different farm? Really?
Oh, we gotta go to that. That'd be so cool.
That's like literally legit like 10 minutes from my house, my old house.
If you
Or
look,
five-
all
I thought
right.
he said a farm in
Let's keep
Yolonia.
going. If you look at Saturn's interior, it's interior kind of like Jupiter. It's gas on the outside, and then as you go further and further in, the hydrogen gets more compacted and hotter and hotter, and it becomes liquid metal hydrogen. That's the white part here. Liquid metallic hydrogen. And that rotates around and creates Saturn's magnetic field, which is the second biggest magnetic field of any planet after Jupiter. It's 1/20th of the magnetic field of Jupiter, but it's still 580 times as strong as the Earth. So Saturn has a big magnetic field created by this liquid hydrogen, liquid metallic hydrogen. Now, if you go deeper than that, the material gets even more compacted, and you start to get some rocky stuff, and it does have a rocky core, just like Jupiter does, that has heavy metals and rock and that sort of thing. So there is a rocky core, even though it's a gas giant. But you could never make it down to that core because it gets so hot, and you had to go through all this liquid metal to get there. That's incredibly hot and incredibly dense. So anyway, Saturn is a gas giant, kind of like Jupiter, with similar interior. Isn't that cray-cray? They still saying cray-cray?
I don't know about
Quit saying that.
Amy, I love
I
that.
liked it.
You should bring it back.
Talked about the rings. Here's another look at the rings. Saturn has a tilt like the Earth has a tilt. The Earth, what's the tilt of the Earth? Do y'all remember?
23.5.
23.5. Saturn's tilted a little more, 27 degrees. So Saturn's kind of like the Earth with its tilt. Sometimes when we're looking at Saturn, we see the underside of its rings. And when Saturn's on the other side, we see the top side of its rings.
This is a picture.
So if the rings were like this, what I need is a frisbee.
Oh, I have one in my car.
Me too.
But it's laying like, or a plate, it's laying like a
have one in my locker.
dish. And so if it's on this side of us, we see the top side of its rings. And if it goes around to the other side of us over here, you see the bottom side of its rings. Does that make sense? And so it depends on where it is compared to the Earth. Yeah.
The more of a tilt it is, does that mean that there's more extreme seasons?
Yes. Great question. Great thinking. Yeah. The more of a tilt.
So
the more
they-
extreme
so-
the seasons. So what would have the most extreme seasons?
The pole.
Which planet? Which planet's tilted the most?
Uranus.
Oh, yeah.
It's not.
Is extreme seasons.
Oh, yeah.
However, it's very far away from the sun, so it's not getting much heat from the sun anyway.
That's
Does it
right.
ever freeze, like, over?
Oh, yeah, like freeze compared to the freezing point of water. Yeah, it's always frozen.
Oh, okay.
But other things don't freeze at such
It's a gas, though, so
high temperatures.
Uranus.
Even gases can freeze.
Yeah.
And once these gases get colder, they'll stop moving so fast, and they'll become liquid, and then they'll become
Like
solid.
a vapor. And
Like frozen carbon dioxide. Carbon dioxide is a gas on Earth, but if you get the temperature cold enough, it becomes dry ice. And that's frozen carbon
Okay.
dioxide. And that's what Mars has.
Gotcha.
Can't Uranus also get up to like 600 over, like Fahrenheit?
Uranus?
I mean,
Well, if you go deep enough into the planet, yes, but not on its outer atmosphere. Yeah.
Is this a picture or a drawing?
That's a picture.
It's really colorful.
It's false color. So they've had a computer color it so you can tell the difference between the layers. That's a good question. Good point. That's not how it would actually look. They've had a computer-added color. Okay, so the ring. Let's talk about the rings a little bit. You have this this little break there. See that? That has a name. That's called the ink gap. And that break there is called the Cassini Division. These are spaces, open spaces in the rings. How do open spaces in the rings get there? There's two ways that open spaces in a ring get there. One, you can have a big particle in there that's moving around, sweeping up all the little pieces in that area. Another thing you can have is what's called a shepherd moon, which I think is a really cool name. Shepherd moons are moons that sit just outside the rings, and their gravity pushes or pulls stuff out of that area. And it has to do with the laws of gravity and physics on why that would occur. But if you look at the way the gravitational forces pull on things and the way these shepherd moons move around, sometimes you can add their gravities together in places and it'll clear out a little spot. I don't fully understand it, how it works.
Are they called that because
you have to do the mathematics. They're called shepherd moons.
Are they called that because of Alan Shepard or like?
No, because
Shepherd?
you know how when you're shepherding, you're herding
Yeah.
sheep. So it's like herding particles out of one place. And so shepherd moons can also hold particles in one place too, and keep a ring and keep the particles of a ring from going too far one way or too far the other. So shepherd moons can cause these rings. The rings were once numbered. Or lettered. When they first discovered them, they were lettered. You have your A ring on the outside, and your B ring there, and your C ring there. So that's A, that's B, and that's C. And that's how they named it at first. And then later, they discovered even more rings and had to go rings further outside, and rings further inside. And so they called it like, I think D, E, F, ones that they found further inside, and then G and H they found further outside. I don't remember, they've added, yeah, see there's a G ring even further out, and there's a D ring further in. Anyway, these rings have been given letters, and it's not all in a nice order. Like, if you had to name it now, you could start from the outside and go A, B, C, D, E all the way. But now it's confused. It's like, or if you start from the inside, it goes D, C, B, A, F, G. It's like totally out of order. So anyway, just thought you might want to know that. The most visible one is this one. That's the B ring. And the visible one outside is the A. So A, B, and what's that gap called? Or that?
A shepherd moon?
No, what's that? What, we have a name for the space itself.
Ink, yeah.
That's called the Cassini Division right there. The Cassini Division. And that little space there is the ink gap. Cassini Division, ink gap. And you could see those with a telescope from even far away. We'll try to take a telescope out there and look at Saturn if it's out. And even through our little telescope, you can see the ring.
Oh my gosh, that's so cool.
You know the scientist Carl Sagan?
Yeah.
He was compelled to become an astronomer because he took a telescope when he was a kid and was just pointing at the sky, and he saw the ring of Saturn. And he didn't know any planets had any rings. He thought he'd like discovered it or something. And he was like, "Oh my gosh, what is this? It's got a ring around." He's one of my favorite scientists. Saturn has a really cool moon. It's called Titan. Now it's got a bunch of moons. Saturn has a bunch of moons, but it's got one big one. It's called Titan, and here it is compared to the Earth. And the cool thing about Titan is it's the only moon in the solar system that has an atmosphere.
Whoa.
So it's got gases around it like Earth and Venus have. And but its gases There's its atmosphere. It's let's see, what does it say about the gases? Nitrogen, mostly nitrogen. And it's got a lot of methane in the atmosphere and ethane in the atmosphere. Methane is CH4, ethane is C2H6. And these gases, have you heard of methane gas? On Earth, it's a gas because we have high temperatures on Earth. But on Titan, where it's real cold, it becomes a liquid. And so methane and ethane form liquids on the surface of Titan, and it forms big oceans and pools and lakes. There are lakes of methane and ethane on Titan. And if you remember, methane and ethane, those are flammable gases. We use those. That's natural gas. Have you ever heard of natural gas?
It's about to ask if we could take some of that.
Yeah, you could burn that. So if you had oxygen on Titan and you struck a match, the whole planet would blow up. But there's no oxygen on Titan, and it's real cold, and so that wouldn't happen. But anyway, it's just interesting that because this has lakes and rivers and oceans of liquid methane and ethane, it looks a lot like Earth, because Earth has lakes and rivers and oceans. And so they've actually flown a probe. The Cassini mission went to Titan, and it orbited Saturn, and it dropped a probe into Titan that parachuted down and took video, and you can see the it's called the Huygens probe, and there's a picture from the surface of Titan, and I have a video about Titan that we're going to watch. Isn't that cool? That's from the surface of Titan. You can't see any. This isn't liquid here. It didn't land in. They didn't know if it was going to land in one of the lakes, and they thought they might lose it if it sank into an ethane lake. But it didn't. It landed on solid ground. And I think they found out when it was going down there isn't as much liquid on the surface as they thought there might be. But there are some pools. So I got a video here of Saturn's moon Titan. If I can find it. Saturn's moon Titan, y'all. Saturn cloud rotation. I can't find it.
Why do clouds on Earth look so different than all the other clouds we see? Or is it just like the depiction?
Look, what do you mean different?
I don't know. Ours just look like more spread out than clouds.
Than clouds on other planets?
Right.
Well, they're made of different stuff. It's not water clouds, so they're going to have different properties.
That's true.
Okay, hold on. I know what I'll do. I will open up. Here we go. Now we're doing it. Okay.
Yeah, it's fine.
What'd y'all do?
No, that's not what I wanted.
Like
This
just
is what I
running
want.
stuff? Or
Here we go.
was it productive running?
Majestic.
That's who this
This is the voice.
Quiet, please.
The rings are probably a moon graveyard. Millions of fragments, remains of long destroyed, fractured moons. And 700,000 miles beyond the rings is the largest of Saturn's moons, Titan. Titan is shrouded from view by miles of haze, a smoggy atmosphere unimaginably worse than a bad day in Los Angeles. The surface of Titan has never been seen, but infrared studies suggest that when we break through the atmosphere, we will find a world strangely familiar.
So this video was made before the probe went through there.
When was this video made?
I don't know, 15 years ago.
Yep.
Force track.
For nearly 1 billion miles from Earth is a moon that looks like home.
Welcome to Titan, coolest moon in the solar system. It's got lakes, mountains, and oceans.
Titan may look like Earth, but the lakes are made of liquid natural gas, a chilly 300 degrees below zero. It's so cold it will freeze your skin right off your body. But with the right suit, you could have a blast, swimming in a world with just 1/7 the gravity of Earth.
The great thing about swimming on Titan is because the gravity's low, you can pull yourself clean out of the water like a dolphin.
Imagine swimming like a dolphin in a lake of flammable natural gas, 1 billion miles from Earth. But you ain't seen nothing yet.
One way to explore Titan would be by balloon. Because unlike any other moon in the solar system, Titan has a thick atmosphere, and that makes it possible to fly.
An atmosphere means that Titan has sky, clouds, wind and weather, and air in which to float. In fact, NASA already has a balloon design, and plans are in the works for a plane and even a helicopter.
Oh, that's so cool.
Within 50 years, there may be a balloon floating on another world.
That looks so
But on
cool.
Titan, we can achieve the ultimate dream in flight.
In fact, the air on Titan is so thick and the gravity so low that all a human being would need to fly is a small pair of wings.
Using a set of wings only 10 feet across and powered only by a
No.
we can soar like a bird. We can climb into clouds of natural gas. When the clouds get too heavy, they release a downpour. On Titan, it doesn't rain water, it rains fuel. The drops, twice as large as on Earth, fall like snow.
Oh, that's cool.
The petrochemical rain erodes the landscape, creating a mirror image of Earth, of valleys and hills, and filling the lakes with an explosive mix.
If there were oxygen on Titan and you struck a match, the whole place would blow up.
A deafening roar has enough fuel to power the Earth for 50 million years. It goes up in flames.
How cool is that?
So
Wait.
would that atmosphere go away if people
Because they lit a match and everything.
Yeah, but there's no oxygen in the atmosphere, so it would never ignite.
What if
But
like
there's cool science fiction stories about aliens that need fuel, and they go to places like that moon, and they suck it all up with their equipment and
Dude, I want to meet an alien.
fly off. It's natural gas. Yeah.
what if like a meteor or something hit Saturn? Wouldn't it make enough heat to, when it went through the atmosphere?
It would, but there's no oxygen. So it can't react. It can't burn. It can only burn if you have oxygen. And
Gotcha.
there's no oxygen there. So, Saturn's big, Titan is cool. We got a lot going on up there.
Everyone's all hooded up.
You need to know those. Now, there's another moon that you probably want to know about. It's called Enceladus. Now, Enceladus is real small, and it's kind of like Europa. It's got internal heat, due to the stretching and the tidal forces, the same as Europa and Callisto and Ganymede. And internal heat heats up in the middle because of the elliptical orbit, and we know it has some undersea oceans, and you can see water coming off of it through cracks. And the Cassini spacecraft took pictures of it and took measurements, so we know that one has an undersea ocean too. Maybe there's life there. So there's an undersurface ocean. So that's Enceladus. We flew several missions to Saturn. Voyager 1 and Voyager 2, they passed Saturn, took good pictures, and did gravitational slingshots. The Cassini mission, that's the one that launched the Huygens probe. And Cassini is still, that's what the Cassini spacecraft looks like. That's still orbiting Saturn today. It's been there for 12 years, and it's still going. So it flies around, takes pictures, and you can see videos of all
Do
that
things
stuff.
like that, do they come back to Earth, or do they just let them free into
No,
space?
they don't come back to Earth. That one will stay in orbit around Saturn, and it'll eventually fall into Saturn. Die inside Saturn. You want to see videos? I got a lot of videos here, so watch these for homework, but here's one on Enceladus. Oh. See how Enceladus looks? It's a kind of a weird looking moon. Oh well. I don't think we have time for these other ones.
I want Lord Farquaad to narrate.
One of the key discoveries that the Cassini orbiter and the Huygens probe revealed for us was discovering the liquid lakes on Titan. Cassini was able to look at the lakes, get a sense of the coarse composition of the lakes, but nothing about the organic molecules that are dissolved in the lakes. The Titan-Saturn system mission is a 3-in-1 mission with an orbiter for Titan, a balloon that will float through Titan's atmosphere, and a lander that will splash down on one of the northern lakes of Titan. This mission will actually go into a lake, sample the liquid directly, see what the organic molecules are that are present. The Titan-Saturn system mission also will go to Enceladus, a tinier moon, 1,000 times smaller than Titan, which has volcanoes, geysers essentially, that are spewing material from the inside of this moon outward. And it's a chance to see whether there might be molecules that would indicate that life has actually formed within the source region of these geysers. These geysers have water ice, and we strongly suspect that there's liquid water in the region that these geysers are coming from. We know there are organic molecules there because they've been measured by Cassini. The ability to follow this up quickly is essential because with Cassini-Huygens, we have now trained a generation of scientists who are ready to take a new generation of instruments and capabilities back to Titan and Enceladus and really answer the questions that Cassini-Huygens has left for us. And that continuity of knowledge and of enthusiasm is essential and very difficult to maintain in the outer solar system because trip times are so long. The Titan-Saturn system mission really is Jules Verne realized. It's a kind of planetary exploration that we have never ever done before anywhere else in the solar system and can only be done on Titan.